I wanted to work through a couple of binomial distribution problems to give you guys some examples to look at. I'm going to do number 16 and 17 from page 255 at the end of section 6.3. So 16 says, have you ever tried to get out of jury duty? About 25% of those called will find an excuse to avoid jury duty. If 12 people are called for jury duty, what is the probability that all 12 will be available to serve on the jury? So this is a perfect binomial problem. There are two possible outcomes. Either yes, they can serve on the jury, or no, they can't serve on the jury. So there are a few things you always have to identify when you're working with a binomial problem. The number of trials is the first one, and we use the letter N for that. In this case, there are 12 trials. We're going to call 12 people and see if yes, they can serve or no, they can't. Something else you have to identify is what is a success. A success would be, yes, they can serve on the jury. So we want to call somebody up and we want to hear yes from them that they can serve. Well, the probability that they say yes is 0.75. How do I know that? Well, the problem told me that the chances that they say no, that they come up with an excuse, is 25%, 0.25. So if failure is 25% of the time, that means success has to be the other 75% of the time. You can always do 1 minus the probability of success. That gives you the chances of failure. And the third thing you need to identify is R. And R is how many successes are we trying to find the probability for. In this case, part A, we're trying to find the probability of 12 successes, that all 12 are available to serve on the jury. So what we would type into Excel, the first number 12 is how many, is what R is. How many successes are we looking at? The next number is how many total trials we have. So 12 successes out of 12 total trials. The third number is the probability of each success, is 0.75. And in this case, we should actually have false here. Anytime you want just one specific number, like in this case, we want exactly 12 successes, you want it false. So false when you want an exact number of successes. All right, so down here where we actually have the equal sign and make Excel do the work, I need to type false in as well. And it tells us instantly that we have 0.03167. So about a 3% chance that all 12 people say yes, they can serve on the jury. So what true does that's different than false is true actually accumulates up to that first number you put in. So our first number here is 12. If we typed in true there instead of false, true accumulates what are the chances that 0 people said yes, and adds that to what are the chances that 1 person said yes, 2 people, 3 people, 4 people, 5 people, all the way down, etc., to 12. Okay, and it adds all those together and gives you the probability of that whole range from 0 up to that first number. That's what true does. And that's why when we type in true here, we get 1 or 100% chances, because of course, if you're calling 12 people, your results have to be somewhere in here of the number of people who said yes. Okay. So that's 16A. 16B says, what is the probability that 6 or more will not be available to serve on the jury? So 6 or more not available for the jury. Well, how many does that mean can be available? If we had 0 available, that would fit into this category, because that would mean 12 not available. We could have 1 available. That would mean 11 not available, which is more than 6. So 2 would work, 3 would work, 4 would work, 5 would work, 6 would work. If we had 6 available, that would mean 6 not available. 7's not going to work. If we had 7 available, that would mean only 5 not available. So we need to cut it off at 6. We want our successes to be between 0 and 6. So R in this case, we're asking up to 6, which we're going to use the true here. So our chances of 6 successes out of 12 trials, 75% chance of success. And true, we want to accumulate everything from 0 successes up to 6 successes. So let me change that down there to 6. And here we get about a 5.4% chance that will happen, 0.0544. All right, so that's the chances that 6 or more will not be available. All right, if you have any questions about number 16, please email them to me. Number 17. Does crime pay? The FBI Standard Survey of Crime shows that for about 80% of all property crimes, the criminals are never found and the case is never solved. Suppose a neighborhood, a district in a large city suffers repeated property crimes, not always perpetrated by the same criminals. The police are investigating 6 property crime cases in this district. So just quickly to point out, why would they mention that they're not always perpetrated by the same criminals? It goes back to independence here. If they were all done by the same criminal, then once the police caught the criminal once, they're going to stop all the rest of the crimes. It would affect the chances of catching the people for the other crimes because the criminals are already caught. But in this case, they're not all done by the same criminals, and the police are investigating 6 property crime cases in this district. What is the probability that none of the crimes will ever be solved? All right, so let's figure out what needs to go everywhere. How many trials are we running? We're running 6 this time. We're looking at 6 different property crime cases. What is success in this case? Success is we catch the crook. How often does success happen? 20% of the time, because 80% of them are never caught. Failure happens 80%. All right, and what is R? How many successes are we looking for? We're looking for exactly 0 successes. What are the chances that none of the crimes will be solved? So down here, we want to type in 0 successes out of the 6. And our probability here is 0.2. Do we want true or false? We want false because we're just looking at exactly, we're looking for exactly the 0. We're not trying to accumulate anything. So that's what we need to type in and run where it says equals in our cell below. 0 out of the 6, 0.2 false. And you see we get about a 26% chance that none of the crimes are solved. All right. Part B says, what is the probability that at least one crime will be solved? So we figured out the chances of 0. Everything else, any other option would be at least 1. So the quick way to solve this would just be to do 1 minus 8. All right, so if 26% of the time no crimes get solved, that means 1 minus 0, 1 minus the probability that 0 gets solved. That's the answer for at least 1 being solved. All right, I showed it here also in sheet 2 really quick. So again, the chances that 0 gets solved, and then you just do 1 minus that to quickly figure out the chances of at least 1 being solved. Or the other way is a lot longer. You could figure out the chances of 1 being solved. See, I typed in 1 here. Chances of 2 being solved, the chances of 3 being solved, 4 being solved, 5, etc. You add those up, that's the chances of at least 1 being solved, which you see it's the same either way. All right, and that's number 17. Let me know if you have any questions.